Hello class. In this video, we are going to discuss the decision analysis without property information. As we know, decision making is not an easy task, especially considering that we might have a lot of uncertainties regarding the future of the state. Of course, if we know the future state of the nature, the problem might be easier for us. However, in so many times, we do not know the future state of the nature. In other words, we do not have the property information about the state of the nature. There are several rules for us to make a decision without the property information. The first one we call maxim-max. The second one we call maxim-min. The third one we call minim-max regret. I would like to emphasize that in these decision rules, when we calculate for the numbers, we would like to do it backward. For example, in the maxim-max, we compute for the second max at first, and then we go to the first max. In the max-min, we go to the min at first, and then we go to the max. In the minim-max regret, we start with the regret, and then go to max, and then go to min. I'm going to show you the process later on in each individual decision rule. I would like to emphasize that none of these three decision rules can always outperform the others, because the best decision rules for you actually really depends on your status of your psychology. Now let's start with the first decision rule, the maxim-max. Suppose you are very optimistic about the future of the state. In this case, we know the airport will be built at location A or B, but we do not know which location the airport will be built. In your decisions, you have four choices. You have decision A, it means you want to put a land in location A. In decision B, you want to purchase a land in location B. In your decision rule of A and B, you are going to purchase both land in location A and B. In your decision of land, you do not want to do anything. So now, suppose you purchase a land in location A, and if the airport will be built in location A, you are going to get $13 million in your payoff. But if the airport will be built at location B, instead you want to lose $12 million. If you are going to purchase a land in location B, but the airport will be built in location A, you are going to lose $8 million. But if the airport is built at location B, you are going to achieve $11 million. Right now, suppose you are going to purchase lands in both location A and B. And if the airport is built at location A, you get $5 million. Or you lose $1 million if the airport will be built at location B. Of course, if you do nothing, you get nothing for either state of the nature. In the maxim-max decision rule, we are going to start with the second max so that we identify the maximum payoff for each alternative decisions. For example, in this case, we have decision A, B, A and B, and none. We are going to figure out the maximum payoff for each decision. In this case, suppose we start with the decision A, and we know the maximum of the decision A will give us $30 million, comparing 13 million and negative 12 million. Similarly, for the rest of the three decisions, for example, like B, we are going to get $11 million. A and B, we are going to get 5, and 0 for none. Those are the maximum values for each individual decisions. Because we are doing the game backwards, we are going to choose the alternative with the largest maximum payoff. In this case, the decision A will give us $30 million, which is the highest values among all these four maximum values of all those four decisions. So the optimal decision for this game, given that you are using maxim-max rule, will be decision A. Suppose right now you are not optimistic. Instead, you are very pessimistic. You think everything is in the wrong way in the future. In that case, we are going to use the maximum mean decision rule to find the optimal decision. As we said, we solve the game backward, so we are going to start with the mean at first. In this case, we identify the minimum payoff for each alternative decision. More specifically, if we find the minimum for decision A, we know negative 12 is the lower value comparing to the $13 million for location A. And then we can compute for every single one of the decisions. So we get negative 8 for decision B, negative 1 for decision A and B, and 0 for none. In this case, we are going to maximize the alternative with the largest minimum payoffs. And compare all these 4 minimum values, we know that the 0 value is the maximal in this case. So it means doing nothing is the optimal decision if you are very pessimistic. Let us consider the first decision rule, the min-max regret. As we said, we are going to solve the game backwards. So we are going to compute for the regret value at first. We have one equation we call Rij, which denotes the regret level for decision I in state of the nature J. For example, suppose we have a decision A, and we have state of the nature A as well, and Rij will be Raa in this case. Now, coming back to the equation of Rij, we have Rij equal to absolute value of the optimal value among all the decision I in terms of the utility values of all decisions. So we are going to find the highest utility values among all the decisions of A and B, and none for the state of the nature J. For example, suppose state of the nature J will be A, and we are going to figure out which value is the highest right now for state of the nature A by comparing all values of all 4 decisions. And we can easily tell that 13 is the highest value. So the optimal Uij will be 13 for the state of the nature J. Similarly, for state of the nature B, we have the optimal Uij. The highest value will be 11. Now we are going to use optimal Uij minus the Uij itself. For example, in the decision A, location A, we have the Uij equal to 13. Let us go to the regret table as shown below. For example, in the first case of decision A, in the state of the nature A, we have optimal Uij that will be 13 minus the Uij, the 13 itself. So we get 0 for the regret if we purchase a land in A and the airport built in A. Now, suppose the airport will be built in location J. Look at the J, we know the optimal of all decisions in location J will be 11. So the optimal for us for location J will be 11 minus the current Uij, that will be negative 12. So we have 11 minus negative 12. We got $23 million. What does it mean this? It means if you purchase a land in A, but it turns out that the airport was built in location B, your regret level will be $23 million. And that's huge. We can complete the rest of the decision table. For example, for decision B, we continue to have 13 as the optimal for the location A. And we are going to use 13 minus the negative 8. So we got 21. If the airport built in location B, we got 11 minus 11. So we got 0. And the rest of the table can be computed accordingly. So we have this regret table. Based on the regret table, we are going to go to the second steps. The second step will be max in the min-max regret. We are going to compute the possible regret for each alternative decision under each state of the nature. So now let's try to figure out what is the maximum for decision A. We know that between 0 and 23, 23 is a bigger number. So the maximum of the decision A will be $23 million as the regret. Similarly, for decision B, we have 21 regret level. For A and B, we have 12. For the non-decision, we have 13. Now let's go to the last steps of the min-max regret. We want to choose the alternative with the smallest maximum regret. And among these 4 regret levels, we know that $12 million is the minimum one. So the optimal decision, if you are using min-max regret decision rule, the decision of A and B will be the optimal decision. I would like to remind you that there are some anomalies in the min-max regret rules. You need to make sure you find all the alternative decisions. Otherwise, your decision in the min-max regrets could be misleading sometimes. For example, in this case of 2 decisions A and B, you have states of nature 1 and 2, and you have this payoff matrix. We can translate this payoff matrix into regret matrix, and we have this. So based on the min-max regrets rule, we are going to find that the decision A will be the optimal decision. In other words, we prefer A to B. But if it turns out that you forget about one alternative decision, for example, you forget about the decision C, which is available as well, and we have the payoff matrix for C together with A and B, and if we compute for the regret matrix, we have this. Following the min-max regret, it turns out that the decision B is a better decision compared to A right now. Suppose you have the new alternative C, and we now prefer B to A. So it's a little bit misleading compared to the first decision without the alternative C. So in the real decision making, you need to make sure you find all those available alternative decisions and make sure you have a comprehensive set of the decisions over there. Thank you.